Hello guys, now we will solve valid anagram problem. So you guys already know what anagrams are, right? That you can produce same string by jumbling the words. Okay. Now, for example, one anagram and nagaram both are anagrams because if you jumble them, you can get this, right? So there are two properties of anagram. First one is that length of both the strings should will be same if we are comparing. Second, that word frequency will be same, right? So what it means is that, for example, here, although we have three digits, like three letters at both the places, three alphabets at both the places, but here we have T. So here we have like different things, like different alphabets. So it's not a anagram, right? So it will return false. So what I will do is, so first check is, so how to solve it. So concept behind it is how to solve. First, check length of both the given strings, right? Second, after checking the length, we will create a hash map and, sorry guys, so we will create a hash map, and inside a hash map, we will store frequency of each and every character, which means how many times a character is appearing, right? So create a hash map. Third will be that we check. So assume it like this. We insert frequencies of all the characters of a string S, right? Then for a string T, we check if character exists and frequency should be greater than zero. Okay, like it should not go negative. That's the thing. So what we will do is we will check if length of S and length of T is not equal, then return false, right? Both are not like T is not anagram of S if character length is not equal. Second check, create a hash map. So I will call it frequency counter equals this, which is a dictionary in Python, right? First step, update uh, update all the elements and its count in our dictionary. So for I in S, we will iterate, and if mm, if this element I in frequency dot counter dot key, if it already exists in the key, then frequency counter uh, I plus equals 1, else frequency counter I equals 1, right? So this is where we will update the frequency counter, right? Second is check if all the elements of T exist in frequency counter and count should be non-negative. Okay, so if I do this for I in T, and if I in frequency counter dot keys pass, else return false, right? If it does not exist, then we will return false. Now, in this case, what will happen is if it returned in the key, then frequency counter I minus minus equals 1, right? And if uh, frequency counter of I becomes less than 0, then return false, right? And return true, correct. Let's see, let's run it and see the result. So this is true. Yes, this is false. This is also false. So this is the correct implementation. So what we will do is we will uh, copy and paste this solution. So I will just copy and I will paste it here. This is my previous solution and I have created better solution this time. Okay, so return false, frequency counter. Okay, 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 okay. This is our second step. Okay, okay, okay. So this is how it should be. If I run it, okay, it's accepted. If I submit it, Okay. Solution could have been much better, but concept-wise, it's there, and we will soon see what can be the other approach to this solution and to this problem. Thank you very much to for your time, and I will see you in your next problem.